I've actually got Alfred first in terms of opening and logistics. And then that should say overview of EFH is James, not Alfred. Wonder how many more typos there are in this presentation. Hopefully not too many.
If you hand me the notes, I can read them for you. Okay. So I think we can start. Welcome everyone to today's pre-webinar for the EFH hackathon. My name is Alfred Ongere. I'm the founder and CEO of AI Kenya, which I think most of you know about. AI Kenya is an organization whose mission is to democratize machine intelligence in Africa, and we mostly focus on Kenya. So we do events, we run a community, and we also offer trainings. We also run hackathons on behalf of organizations like what we are discussing today, and then we also build solutions. So thank you very much for making the time, and congratulations for being selected to participate in the hackathon. So today's webinar is meant to give you an idea of what we'll be covering during the hackathon for the 3 days next week, starting from Monday. So welcome very much. I will now hand over to James to continue.
Great, thank you, Alfred. And hi, everyone. Good morning for most of you. No, sorry, good afternoon for most of you, since you're in Kenya. So yeah, just an overview of what to expect in the next hour to hour and a half. So I'm going to give a very brief overview of EFH. I'm sure many of you are now familiar with that acronym, but may not know much about what we're trying to do as an organization and an initiative. So I've got a few slides on that. I'll then hand over to Geoffrey Siwo, who is currently in Michigan, who's going to give an overview of the hackathon. So, the kind of questions that we'll be expecting you to answer, some of the design constructs, tools that you'll be using, those kind of things, and how the hackathon itself will be structured. And then finally, Geoffrey will hand over to Hao-Yun, who's going to talk about semantic search and LLM-aided data integration with Gemini. So what we're doing at EFH is kind of trying to reframe how we think about health and particularly disease burdens and how they relate to people's interactions with the environment and environmental change. So picture on the slide here is this is Samburu County Referral Hospital. So it's the kind of main catchment area for people presenting with disease in Samburu in Kenya. We work with this facility quite a lot, and it's up on the slide here because most people who aren't disease ecologists or epidemiologists focusing on the environment and health think of health burdens as being those that present at facilities such as this, so clinic-based burdens of disease. But in reality, the drivers of many of those burdens of disease and the risk factors for those disease outcomes are formed outside of those clinics in the landscapes that humans live in and interact within. So those can be with urban landscapes and urbanization and urban development, which are the kind of the proximal factors that drive health outcomes. These can be for how people interact with their animals and food systems, for things like zoonotic diseases. These can be for how people interact with nature and ecosystems through their livelihoods. So interactions with forests, conversion of land, whether that's for social development or for agriculture. So the view that we're really taking of health and disease is one of, is really a systems approach as to how burdens of disease are formed in the natural environment, but also through people's interactions with environment. And the importance of the environment and environmental change in global disease burdens is borne out in numbers as well. So recent studies show that at least 80% of human pathogens that are tracked by the World Health Organization have some form of environmental mediation. So there's an environmental step in their transmission, or their epidemiology is somehow affected by changes in the environment. And as of 2016, at least somewhere between 24 and 30% of global deaths are due to modifiable environmental factors. And so to give you an idea of how EFH is approaching that problem, I wanted to provide an example. And so in this pictogram here, this represents a rangeland landscape in Africa. And one of the questions that we're asking is, okay, well, in these connected systems where you have climate impacts, you have impacts of agriculture, and they have trickle-down effects on, for example, disease vectors, on livestock health, on biodiversity, which themselves can impact people's interactions with each other, things like conflict. So how do they, cumulatively, how do they result in health burdens at a landscape scale, at the kind of clinics that were in the first picture I showed? And so here we're really thinking about, not just, for instance, malaria or diarrheal disease or the impact of climate on heat, but really the cumulative burden of human mortality and morbidity that results from the interactions of these factors in a landscape setting. And then in EFH, we're really interested in how do you quantify the impacts of interventions in those systems on health. So really turning that question of, what are the health burdens into, well, what are the benefits and returns on investment for health through solutions that could include biodiversity conservation, could include improvements in livestock health and animal health, could include in how animals are managed, and also in healthcare systems as well. What are the returns on investments for health, and how can those be measured? And so this really involves trying to better link the data on how environmental drivers are affecting health burdens, and then looking at how that data can inform interventions and investments in those interventions and returns on investment. So this is my last slide, and what I really want to show here is how the value model that we're looking at this from, and this really ties into why we're holding this hackathon in the first place. So on the one side, kind of trying to better understand how health burdens emerge from changes in the environment and environmental risk factors. There's science, right? There's a lot of scientific research which is being done across the world, which is generating valuable evidence on how environmental changes and climate change are affecting health. And that's in the form of publications, data sets, reports. Then you've also got communities who hold really valuable local and contextual knowledge on health outcomes and how they're being affected by these changes in the environment. And then you also have non-scientists, but people designing projects, for example, NGOs, local development organizations, who may not be publishing data sets or work, but have really valuable information on what does and doesn't work on the ground. Now, on the other side, so that's the kind of the evidence, and the evidence you imagine isn't terribly well organized at the moment, and there are certainly gaps. Now, on the other side, you have lots of different organizations who need this information in order to be able to improve their practices, in order to be able to make money, make more money, and in order to be able to support sustainable development. So these include community development organizations on the ground who need to identify, interventions that can generate net health, environmental, and food benefits in a landscape and for a population. And they're also interested in ways in which health can be measured so as to demonstrate greater impact for their work. Similar kind of questions and use cases exist for conservation organizations. So for them, they're implementing biodiversity conservation, and they're really interested in, okay, well, where are the environmental levers for health in our activities? So where can conservation lead to health co-benefits? And how can those connections be measured in a way that can attract additional investment? For the private sector, so here we're thinking about people who finance that kind of work and investors. They're interested in knowing, well, by linking health outcomes to environmental solutions or climate solutions, what are the additional financial returns on investment? Are there projects in which we can invest that measure not just conservation and health benefits, but also returns with relation to health? In the insurance sector, this kind of data could help to price environmentally driven health risks, to target investments that reduce insurance claims linked to health risks, so the environment, and better really understanding if there are populations who are experiencing health risks from the environment who are not covered by existing insurance products, and so on. I won't go through them all, but there's the importance of this data also relates to development banks and the development of financial instruments for nature and climate that could be linked to health, for financial regulators, and also for scientists themselves who need to understand, okay, well, what are the research priorities at this intersection? Where is my research going to have most impact? And who else is working in that space? So that's what EFH is really trying to do, and what this is one of our first activities as an organization, is to look at ways to break down that barrier between the evidence and the people who need to use that evidence. But what we're really interested in with this sprint is just as a baby step, and a step towards developing a proof of concept, is how can we use generative AI and large language models to enable people who need this kind of information on the connections between health outcomes and the environment, to be able to make better decisions. And with that, I'll hand over to Geoffrey.
Thank you very much, James, for that overview, and thank you all for joining. It's really a pleasure. We're really excited to meet you in the next few days. It's been just incredible to read some of the projects that you have all done. So we are really looking forward to learning from you. We hope this will be an exciting event from the perspective of learning new skills, forming new connections, and forging a future where generative AI can have an impact on the problems we all face. So before I introduce one of our facilitators, Dr. Haoyun Feng, who is Director of Data Science at Elevance Health in New York, I'll go a little bit over some of the key goals of the hackathon. So James has laid out that, science has been advancing at an incredible rate, and science has always been in a silo in many ways, because the people who do the science in many ways sometimes get disconnected from the practical challenges in the real world. Of course, science happens in the real world, but the real world is so complex that we have all gone into very specialized disciplines that sometimes make it hard for us to engage. My passion has always been to accelerate the way we do science, to make science scalable, to make science accessible, and to make the speed of science go faster and faster. And as part of that, computing is a platform that can accelerate the way we do science. Myself, I do a lot of research on drug discovery that involves a lot of trying to figure out how biology works, trying to do experiments, and all of this sometimes happens at a very slow pace. I believe that the more we get to do on computers or in the digital world, the more we'll be able to solve problems faster. I'm originally from Kenya, so it's really a pleasure to connect with you all. And we're looking forward for these few days that we'll spend together. So in terms of practical goals, we have a big vision, but this big vision can be broken into two main elements. We know that science relies on a lot of knowledge. We have basic knowledge. We have new discoveries that are being published in scientific papers or in technical reports. How can we make this information accessible to those who are trying to develop solutions in the real world? Can generative AI help us to better inform those who are not scientists themselves, but perhaps enable them to interact with scientific literature and technical reports? So essentially, that goal is equivalent to taking a system such as an LLM system and enabling that LLM system to contextualize its responses to a specific domain. So broadly, the domain we are interested in here has to do with sustainable development, ecosystems management, the management of biodiversity loss, and public health. But essentially, this is a problem of how to contextualize LLMs to specific domains. The second goal is that, science, in addition to producing new knowledge that is normally shared as text in scientific papers or technical reports, is that science is based on data. And data is really critical to science because data is the primary source that we use to generate evidence. So can we make or can we leverage LLMs to enable organizations that are solving real world problems to be able to interact with data without having to be data scientists in themselves? And this is not to say that data scientists are not critical. I think data scientists are always going to be critical. But the ability to democratize how and who does data analysis would enable us to solve problems at a faster scale. So, James, next slide. So over the period of the hackathon, which is 3 days, we expect that most of the technical work will happen on day 1 and day 2 with all solutions we expect will be developed by 11 a.m. on day 3, which is the Friday. We'll be sharing more detailed agenda by later this week. But over those days, you'll have 2 tasks. So one task has to do with how do you take an LLM and contextualize it to external knowledge. And external knowledge is normally provided in terms of an external corpus, which is, it can be containing a set of documents. In our case, it will just be focused on a scientific paper that will be given to you and will be expected to have an LLM system that can contextualize responses based on this externally provided document in PDF format. And why is this important? So the reason this is important is that you can imagine a scenario where, you're approached by an organization that is trying to implement some sustainable development project. Now, this organization, they are not data scientists, but they know that science is important in helping them design their projects. They know that there are some high-value scientific publications out there, but the problem they have is that even though they have access to that knowledge, they can't actually see how it fits into the project they're trying to design. So this organization, they approach you and basically ask you to build for them a system that can enable them to take the projects they have in mind and try to assess how the scientific paper or technical report can help them to answer some of the questions they have about their own project. And from the application from several of you, it's clear that you have worked with LLMs and try to make LLMs contextualize responses. So essentially, from a technical perspective, this is a problem of semantic search or contextualizing LLM responses, of which one of the primary ways of doing that is retrieval augmented generation, which again, from your applications, many of you are familiar with these concepts. So in terms of the specific task, it means then that we'll need you to leverage any of the LLMs of your choice and see whether, given a set of questions or prompts, can you contextualize the response of that of your LLM system such that the responses are tailored given this specific document, and we'll compare your responses, the responses from your LLMs to responses from ChatGPT as a baseline. Next slide. So yeah, so this basically boils down to a specification that basically asks you to develop an LLM-based tool that takes in one or more PDF documents, and when prompted, contextualizes the answer based on the given set of documents. And as I say, it should be better than the baseline, which will use ChatGPT as a baseline. So again, visually, this is a retrieval augmented generation task, and retrieval augmented generation, or RAG, is becoming very popular. The reality, like in many things in computer science, engineering, or in developing software, is that there are probably various ways of doing RAG, right? You can optimize your RAG in different ways, because you can use different criteria in terms of matching the similarity between your prompt and the similarity of chunks of the document in your corpus. So we hope that you'll be able to do better than the baseline. Next slide. So to do this, we'll provide you with 2 scientific papers on day 1. We'll give you some set of questions or prompts to basically guide you and see whether you can optimize your system to be better than the baseline in terms of contextualizing responses. Next slide. And then on the final day, you'll be judged using a new set of documents. So when it comes to judging, we won't use the same set of documents that we provided you at the beginning, but we expect that the LLM based system that you build can take in any specified set of documents and try to contextualize responses to that new set of documents. So this will be given, it will be used to judge on day 3. I should say that, of course, because this is a very short period of time, we expect that your system is not going to may not have a user interface. It's okay not to have a user interface. So you might still run this within your code. We expect that we'll be able to run your code to see that it works. And we'll basically give you a set of prompts, but you don't need to have a user interface with forms for somebody to put the input. If you can do that, that's great, but that is not an essential requirement. Next slide. And the judging criteria will be shared. End of this week, we'll be sharing with you lots of resources in terms of what will happen on the hackathon day to day, and also in terms of the judging. So remember, task 1 is contextualizing LLM responses to external documents provided in the form of PDF. Task 2 is an interesting one because task 2 is one that is relatively unexplored by LLMs. This is an exciting area because it's essentially making LLMs to be able to interact with structured data, so data that is either in databases or in tables. And in addition to that, making the LLMs to be able to analyze that data. So for instance, you could ask an LLM a question about a table. Maybe you have some items in the table and just the LLM. Can you tell me the number of patients who have this disease on this day based on table? So this is the kind of task that is interesting because it's basically having an LLM as a tool to query databases, but also to do simple computations such as additions. And one of the most exciting things about LLMs today is the ability of LLMs to interact with tools. So LLMs should not try to solve everything on their own. Maybe when somebody asks a question about an LLM getting the average number of, let's say, items in a list, the LLM needs not only to identify those items, but it also needs to do some math, right, to find out what is that average. So this is beginning to go into how to enable LLMs to do things that go beyond sort of like next word prediction. So doing things like arithmetic or even like plotting figures. So this is the second task from very high level. So basically, you can imagine that you have an organization that has some large data sets, which could be in a table. The table rows and columns could include numbers. They could also include the text, and they want to be able to interact with these tables and ask different questions. Some of which might involve simple computation or also simple reasoning tasks. So, for instance, asking a question about comparing whether one item is greater than another item. So the organization has approached you and basically asked you to build a system for them that they can provide like tables or databases to this system, and the system can be able to allow them to interact with those tables. Because every time you need to do an SQL query, right? If you are going to do SQL queries, then maybe you need to have some programming skills. And the way people have solved that problem in the past is that they built maybe interfaces to databases where you can select the items you want to view in a database. And what we're asking here is that can we do it in natural language? Because if you can do it in natural language, then it means you can answer many questions you can typically answer when you have a user interface into a database that has been built. Next slide. Yeah, so I think I've described most of this, but basically one subtask here is basically to ask the LLM to extract information from a database or a table, which is basically to perform a query into a table. And then on top of that, do some reasoning or analysis of the results of that query. We'll go over some of this again on the first day with specific examples, and we'll be sharing with you resources that will guide you more on this. Next slide. So yeah, so for task 2, we'll provide you with one or more tables in CSV format. For this hackathon, we won't necessarily provide you with super large data sets. We'll provide you just with a small data set to be able to build prototype systems. Because when it comes to large data sets, that's a scaling problem. And today, you can scale very fast. Because of cloud, you can build a small system that works with small data, and you can scale it up when you need to. Next slide. So similar to task 1, you will also be judged on day 3 for task 2. And again, we'll give you a new set of tables and try to see whether your LLM can interact with a new set of tables. So in other words, we do not expect you to hard code any of the table variables that you work with on day 1. because the tables can change. We want you to have a system that can basically interact with table no matter what that table is. Next slide. We'll be sharing several resources. So of course, a lot of this work, because it will involve LLMs, you'll need to manage APIs. A lot of this work will involve working with LLM APIs. So we'll be getting you some API keys. We'll use an IDE that allows for collaborative, like, coding. So this is basically like a notebook. And we have selected this platform called DeepNote. And then also, some of you are already familiar with this because we had it in when you are doing the applications, we ask some of these questions. So we'll be sharing a lot more resources on some of these platforms like LangChain or Together AI that we hope that you all will incorporate to some extent to enable you to build robust solutions. So thank you again. I'll now hand over to Haoyun, who will give a demo on RAG as well as on how to interact with use LLMs to interact with tables, and this will be using Gemini API. So thank you. So over to Haoyun. And at the end, we can have questions. So you can hold your questions until at the end.
All right. Yeah. Thank you. Thank you, Geoffrey, for the intro. Yeah. And hello, everyone. Nice to meet you, everyone. So yeah, very excited to be part of this hackathon event, and really glad that I can help here. So okay, is my screen visible?
Yes, we can see it.
Okay.
Yes. Maybe do you want to do like full screen?
Yeah.
Sure. See if I can. Oh. Yeah, I'll just leave this way. Okay, so I think just as Geoffrey and James and Alfred mentioned, right? So the overall objective, we want to make science, data, and insights more accessible to everyone, and to inform the effective global intervention to improve the health, right? So that's the overall objective. And in order to achieve that objective, so we want to provide you a suite of tools. So for the demo, so I'll basically just introduce some of the tools. So first of all, so I'm going to introduce RAG, Retrieval Augmented Generative AI. Geoffrey already covered that intro, and I think a lot of you are already familiar with it. And then function calling, so you probably are also familiar with it, and the AI agents. So yeah, so I'll first give an overview on those high level. So I think they are LLM usage patterns, and then I'll talk about like the tools available for those usage patterns. So yeah, so retrieval augmented generative AI, the overall objective is that so we want the large language model to answer questions based on the latest information, right? So real-time information. So we know that large language models are trained using articles and knowledge base, and the knowledge the LM has only based on the articles that was used in the pre-training, right? But a lot of times we want to ask questions like, what is today's weather? Or you want to ask a question about a latest scientific research publication, right? So that's where we need to use the information retrieval or a search component to augment the large language model. So so this is a diagram for RAG, right? So you first receive a user query, a prompt. And then for RAG, you have to have a document store. So you use the user query to find a relevant document from the document store. And then the large language model will take the article from the document store and the question. So the document will be as part of the prompt as the context, and then send the entire prompt to generate a response, right? So you basically augment the large language model's knowledge base using the document you retrieved. So yeah. So first of all, there's a large language model. You can choose different large language models. There's ChatGPT. So in my demo, I'll use Gemini. And there's a lot of open source large language models like DeepSeek, which is very popular recently. And for the document store, so there are also a lot of different tools for the document store. So I'll be using ChromaDB because it provides a very easy interface. So it's easy for the demo, but there's also choices as Elasticsearch, Neo4j. So there are like different choices there. And so in order to process the document, you first want to trunk the document. So I think in my demo, I just simply trunk based on pages. But you can also use token count, or I think the best way is to trunk them based on the sections, right? So yeah, so you have choices in document trunking, and then the PDF parser, you have also different choices there. So in order to achieve the semantic search, you will need a embedding model. So I use text embedding 004, available from the Google AI Studio. So you can also use like a BERT, Roberta. There are a lot of choices there also. And the different embedding model may have like different knowledge, right? So based on your specific task and use case, you want to choose the right embedding there. And overall framework, so there's a long chain. It offers a lot of tools for RAG, right? So it's a very easy integration of the different tools, and also provide an easy wrapper for some of the document store. And pedantic, so it can ensure the data format in the response. So yeah, so this is RAG. So let me just jump to the demo. Okay. So yeah, so I'll try to run it. If it takes too much time, then I'll just go over the code here. So yeah, so first of all, I installed the Google SDK, and then import the generative AI SDK. So this is so if you follow this link, you can get the API key. It's a very easy step, just a couple of clicks, and then you can pass the API key here to the Google generative AI configuration. All right, and then so you can check out what are the embedding models available in there. But you can also like mix match. You can download like BERT model and just use BERT model here. So then, yeah, so this is the PDF parser that I chose. It's just very flexible and give me a lot of information from the PDF. Let me see if yeah, I think I need to install this one. So then I have this paper. in my Google Drive. And then, so I just open the file and then read page by page and attach the pages into a list. So this is the paper that I used. So it's a Genie, it's a system from, so yeah, it actually like generate a game from a picture. So basically like you give a picture and then it will make the object move, and you can actually interact and the object will move accordingly. So it just automatically generate that game. Is a very fun paper. Okay, so now I'm going to embed the pages, right? So I'm going to embed the pages from the paper, convert them into embeddings, and index into ChromaDB. So yeah, probably need to install here. So okay, so in that indexing step, I import Chroma, and I use the Launching chat prompt template, and I use the Google Generative AI embeddings. So yeah, so this is so I specify the embedding model that I want to use, and then so yeah, and then I need to convert my original pages. So they are just a list of strings, right? A list of text. I convert them into the document data type that is required by the Longchain document store for indexing. Right, so this is that for the conversion. And then I use this command, right, to index the docs into ChromaDB. I think that arrow is fine, actually. Okay, let's run through. Right, so then I give the question, and I first retrieve the relevant document based on the question from the DB. So I use the similarity search with relevant score, and I use a query to find the document. So, and you can see like I use the results here, right? So I basically construct the context for the LM using the documents available from the results. And I also have a prompt template. So I'm going to put the question there and the context there. I have the Google Gemini model. And then I'll just use the model to generate content using the prompt. So I use Longchain chat prompt template to connect the prompt template with the context and question. So now my question is, what is a latent action model? And here, the large language model give me an explanation based on the context in the paper. And then I'll talk about a little bit about how to use Pydantic, why is it useful. So Pydantic is actually a way you can actually specify a data type, right? So for example, my data type is, so my answer, I want my answer to contain 3 different components. So it should have a topic, an answer, and an answer to non-technical people. So every answer I want to contain the three parts. So then I can specify a parser, a pedantic output parser, using and pass this answer data type into that parser, right? And then in the prompt template, I have a format instruction, and my format instruction I will generate it using this parser. So in that way, I'll get the prompt instruction to make sure the output will follow the specific data type. Okay, so now if I generate the answer here, right? So you see the topic is a latent action model, and so there's an answer, and there's an answer to non-technical people, right? So imagine you are trying to understand what someone's doing in a video. So basically, the answer to non-technical people are usually like just use more metaphors and to make sure like people can understand the technology using their day-to-day concept and knowledge. So this pedantic library is actually very useful in a lot of tasks, because like when you generate insight, you want the insight to be to follow like specific format. So it's very useful. All right. So this is red. And now I'm going to the function call because mainly I use the function calling for the data analysis task. So basically, function calling, right? So it's a way to reliably connect LM to external tools to enable effective tool usage and interaction with external APIs, right? So in that way, so you basically have a large language model that will decide. So you gave a task to the large language model through natural language, right? And then this large language model will decide which tool to use, and the tool will interact with the environment to achieve that task. So, for example, if you want to build an application from a free text user query, automatically update the user's calendar, right? So then your large language model basically is used to understand the query, and it will use a tool, and that tool will interact with the calendar, right? So the tool will take the command from large language model and update the calendar. So that's one potential use case. So you actually through the tool, you change the environment, right? And another way is so your tools will interact with the database, right? SQL database, and to achieve certain data analysis tasks. So in the demo, so I again use Gemini large language model, and I use 3 tools: list tables, describe table, and execute query. And they interact with a SQL database to achieve the task. And yeah, I'll get to the demo. Okay, again, same step to set up the API key for Gemini. And here I'll use the SQLite so that I can have the SQL table database and basically insert data into the database. So a computer store, and in the computer store they're selling laptop, keyboard, and mouse, and they have salesperson Alice, Bob, and Charlie, and they have and in the orders table it records the different orders that made by the customers, and it also stores the staff ID and product ID. So this means David Lee bought a laptop from Alice, right? So you have 3 tables. And there's a function execute query. So it will take a string against the database. Thing we want to make sure is that you concise and informative function. And in so I provide a system instruction. The system instruction specifies so then I start a chat, right? So with so So yeah, so there's one table. So you can ask a follow-up question. So how much is it, right? So you forgot the price and so if you run this, it will give you the mouse. We'll ask a harder question that requires. So you can ask the cheapest product. Okay, so you will first list the tables of describe tables. It constructs the query and executes the query and answers the question. Cheapest product. Yeah. So if you want to run a so it can handle it better. So now let's check. So yeah, so let's look at the mouse is the cheapest product and it's so this row, right? So Frank bought the mouse is Alice. Okay. So then the LM response, you can the goal. So our inspection list tables and got products, staff, empty table automatically generated by SQL. LM describes the products table. Got the and then describe the staff. Command. So another of using function call is that answer you can inspect, right? So you can trace generated and you can reproduce that arrow. Generate free text answer from a free text. Not even reproduce it, right? So next time you run it, in this way you always generate code first and the answer. So any error you got, you can trace back. So that's another advantage. Okay, so next, AI agents. I think it could be used. And yeah, and also so there is auto-gen in the tools available, right? So AI agents. So in a way, function calling and RAG. The agentic workflow library will provide you. So the major component, you can imagine there's a sync agent, can reason and plan for actions to accomplish the task. The action agent, right? So this tools that the sync agent can use. Agent basically plan all the different actions. And then so the large language model can to take the actions and afterwards those actions. So those are so your observation can be good planning and I have successfully achieved the task. And the sync agent will decide it will terminate because the task already so in that way you can achieve task and applications so that are available include AutoGen from Hugging Face. AutoGen and LangGraph are also very popular LangChain. So yeah, so they the tools. So let's show the code here. I think this example the small agents you can use the code agent. Right, so here you use a model served from Hugging Face to pass a piece of code the agent will automatically debug this code, output the right results. So in this case, you don't need any external, and you just pass the model. So I did from for I in the range of, and then I pass the code to the, say I have some code that creates a bug, please debug, return the final code. Somehow at first, so in the first iteration, you will get an, and as you can see in the step 2, but this arrow is still there. Index out of bound arrow. It corrects this part. So then it outputs the correct code. So and so the agent can fix that bug. Yeah, Geoffrey, do we still have time? If we do, I can this one, or
Yes, we
so the task here is, I want to give a free text. So, and also I can give a very vague command. Understand this command and know exactly what it needs. Actually, use and based on the command, it will to understand what exactly is needed. Image generation tool. So after it understands what generation tool to generate the image. Yeah, so this is a text to image model. It's a diffusion model. And then available from small agents. And then you just simply pass all the, and the query is so the agent has to understand latest movie and what car is it? Car. Okay, so it first generate the code. I think to get today's state. It use web search movie. And also web search the car driven by James Bond. Got who's James 7? So these are the article line. Okay, a little bit failure. But I think it got the answer. So to probably rerun this so it will make sense. So and it's a like an API failure. This is a it's an API failure. Turn the latest movie is No Time to Die. And the car James Bond. So then it's search car James. Sure. Maybe not. Yeah, I think this one.
Oh, okay. So we'll also be sharing in the resources for the hackathon. So yeah, so you can all play around with it. I know it's the valuable thing is to the new technologies like coming up, try out some really fast. So I think there's value that like Gemini, right? Because there are many like you can pay of experts, right? Which we know that even by state of the art like models like GPT-4 Omni, right? When you use a mixture of experts composed of open source creativity. And yeah, thank you so for sharing the demo. It's been true. Again, we'll share this with the hackathon participants. Even though, like, you know, you're generating an image, is an interesting how to interface LLMs, a web browser. And, you know, once you have access to a web browser, so
Yeah.
even in the task that we give you for the hackathon, even if you want to contextualize the response on, who knows, maybe finding like, you know, what are the documents are related better.
Yeah.
So there's a lot of like, and you know, OpenAI just last week, or a few weeks ago, LLM, can you like find me like a flight ticket from how humans interact with computers that will change, even change APIs, right? Because currently you need APIs to have a Google API, like for search to interact with that, but can just go straight onto the user interface, right? Then we can take like any kind of questions from the demo that we had, but this is also a session to. So yeah, so any questions? I know the tools, and the answer is yes. Generating workflows that can be reused. Times they're also like, they can be limited when it comes to the code and play around with the code to change things, right? So
for the hackathon, we have a total prize that will be distributed to the winning teams on the hackathon day, but the total prize will be split across all the winning teams. Yeah.
the second question, which was on the team. So we will have around 30 participants already confirmed. So we at least 5 people per team. Yeah. We assign people to like teams. We look at like your scale. Will be there to support you. We want like the best. So even though this is like there's a prize, but also it's very. If you have questions, please ask them, and where we can support you if we know like how. So there's James about like we'll be offering transport accommodation.
Yes. So and we'll communicate that in advance as well.
Yeah,
Alfred,
thank you. And then yeah, okay, and then also the venue. So yes, iHub on.
Yes, Jahazi Bill will share the exact pin and directions of how to.
So for the participants,
Yes. Across the 3 days and also be available on the last day as are announced. So you have to be there. Yeah.
so somebody asking in terms of evaluation. Thing like your tool, you of course metrics, because actually sometimes when you use metrics that are not tied to the leaderboard, if you have ideas around the evaluation metrics, because this is also like learning, and though we do not commit to change our evaluation metrics.
Maybe just to add on that, for the is being decided by human judges, so we are not using the final indicator of the winners. So you will share a link, a viewable link to your work. And they will have a rating system in terms of how good they.
Yeah, so custom models. So for this, and also strategically, we want to be custom models, because we believe that
The second question on the GPU provision, notebooks that will provide in them, so some basic CPU and also within. So we wanted everyone to at least have for it. But in terms of building the custom models, there are so many layers to tackling the problem. To realize what layer are you really optimizing. So we want to see how smart you can get given time of the hackathon.
And there's a question on even like running DeepSeek. We are planning to use, like Together AI that has the latest DeepSeek models. We would run, especially for DeepSeek, to have it contained within whatever.
The next question on snacks and food. You can just come prepared to have things to bite on. Thank you. James and I, that will include sources for the hackathon. It will during the event. So we will have those resources shared.
So whether we'll have some days online. So for the 3 days, it will be and then also we'll share with you like for like what time do we start in the morning is
Yes, from 8 a.m. So the event venue will be ready early. You can start networking and have a bit of
questions. We just about
on the prizes. Yes. So Terry, we had hackathon day, and also on the resources that we will share on your email either tomorrow or before the end of the week. So you can keep raising any more questions you have to us on email.
about accommodation. We're planning allowance. Is that right, James?
I'm just looking at Mark's question about, so yeah, I think to find somewhere to stay, and then we'll provide an allowance that will, rather than booking accommodation specifically.
And I think everybody, maybe you could let us know in terms of like whether you need accommodation.
In case you'll be having challenges get
Yeah, fantastic. Well, thank you, everyone. I answered all of the questions. Please feel free to email us if you have any additional. Hayun, and looking forward to meeting you all next.
Thank you. Yeah. I'll talk to you about.
Oh, okay. Yeah, thank you so much.
Thank you.
I'm really looking forward to seeing you two next week.